Hi, welcome to Martin Precision Tools. I'm Dustin, and in today's video we're going to be talking about machine alignment. Now this is sort of an extensive subject, so we're going to break it up into two videos. The first one being we're going to be talking about the head and everything connected to the RAM, and the next video we're going to focus on the frame here, so things like the table, the saddle, and the knee. At the end of the video, we'll have a little discussion about whether or not you should consider rebuilding your head, because in this video we're focusing on the head. And then in the next video, when we're focusing on the body, we'll talk about whether or not you should consider rebuilding the body of your machine. So feel free to subscribe to the channel so you can get notifications when that video is available. Okay, so these are the indicators and stands we're going to be using for our testing today. We got two Noga stands, and we have two indicators. Both of them are 10th indicators. This is a dial 10th indicator, and that's a test indicator. The dial 10th has a little bit more range, and it's a little less jumpy than the test indicator. However, there is more force required to use this indicator, so as long as it's in a rigid setup, it should be fine. So even before we get to spindle tolerances and loads, we want to just have a quick look at our setup. We want to make sure that the head is as far back as it'll go for the particular job we're doing. The closer we are to the column, the more rigid the setup. Going to make sure that all the bolts are secured, and we're going to make sure that the head is properly torqued down to the RAM. Alright, so what defines our spindle load? Well, this does, our end mill. So in this case we'll be using a 1/2 inch end mill for flute, and we're going to say that our chip load is 1 thou per flute. So using some math, which we're going to scroll by here, it works out to about 5 or 4.8 newton meters of force per tooth, which means that the overall load on the spindle is about 17 newton meters of force, which is equivalent to about 5 pounds of force on the spindle. Now, when you're actually using the hand wheel, you can feel that you don't have a lot of force when you're making a good cut. And that's because you're not putting a lot of force on the spindle. So it's important to know that, because when we start checking for play a little bit later, we want to make sure we're putting a realistic amount of force onto the spindle, because you can put excessive force on the spindle and it will deflect, and that is not a helpful number for what we're trying to do. So when we do these following tests, we're going to do a test where we just put pressure onto the quill housing, which will give us some indication of the deflection that we have in the entire system. And then we'll do tests where we put the indicator onto the quill itself, because then we can just check the bearings, the run out, and the play from the bearings. So it's important to know the overall deflection in our setup, but if you're trying to just rule out your spindle, then you need to attach your indicator to the quill directly and leave a little bit of space between the quill and the quill housing, so you don't get a false reading by the quill housing pressing against the indicator stand or something along those lines. And then here's a demonstration. We're just going to put about 5 pounds of load on here. We see we do get some deflection. Overall, we're looking for no more than 2/10 of run out from the inner taper and 2/10 of play when we put a lateral force on here, or when we put a force on from the bottom. Again, the indicator will be mounted to the quill, so that way we can just keep our measurement isolated to these two components. If you're trying to do a force measurement, make sure not to rotate the spindle, because if you do, you can get a lot of error in your measurement. It's not even moving. So that's good. And my hand pressure is about 20 foot-pounds. I measured it earlier. Tense indicators are a little jumpy, so this is good. Overall, this is pretty good. Now, this machine did have issues with its head, and we rebuilt the head, so I'm satisfied with that. The taper does need to be reground. I acknowledge that, and when the taper is reground, it should be a hollow ground. What I mean by hollow ground is we should be making contact here, and we should be making contact here, and the middle area should be a void. So for comparison's sake, we have a quill over here with a spindle in it that's had the taper ground. Okay, so now we're going to try checking the vertical play on the spindle, and the way we do that is we set up the indicator so it's on the bottom of the spindle, and we're going to apply some vertical force and see if it moves. Okay, that's not moving. We were looking for N 2/10 or less, so we're doing well there. Alright, well, thank you for watching our video. So as mentioned before, if you are experiencing more than 2/10 of runout at the spindle taper, or you're experiencing more than 2/10 of play, then you really should have your spindle rebuilt. The spindle is the core of your machine. If you have other problems with your alignment, you can generally work around it. You can't work around a bad spindle. So, best of luck, and we'll see you in the next video.